Bismillahirrahmanirrahim. Welcome back to my channel. Back with the video, and this video is going to be a little bit different than what I usually make. So there's something called a Great Internet Mersenne Prime Search, where different researchers around the world, using distributive computing, they discover prime numbers. The largest number that was discovered, which is actually a Mersenne prime, is on October 21st, 2024, and this number consists of 41,024,320 digits. So what Mersenne prime basically is 2 to the prime minus 1. If you calculate this, 2 raised to any prime number, and if you subtract 1, that number is also a prime. That is known as Mersenne prime. So what we're going to do in this video, we're going to use our software-defined radio platforms. I have both of my HackRF and my PlutoSDR, which is connected, and I have downloaded this Mersenne prime. And if you were to just look at it, I'll show you. This is a huge text file, and we're going to transmit this text file, which consists of approximately 41 million digits. And we're going to try to transmit that using our HackRF, which is a software-defined radio platform. And we're going to try to receive that using HackRF PlutoSDR. So both of these devices are connected. And this is how big that prime number is. So it's a huge prime number, and that consists of 41 million digits, and we're going to try to transmit that using HackRF, and we're going to try to receive that using HackRF PlutoSDR. So in order for me to do that, I'm going to open up my terminal, and on one side I'm going to open up my GQRX. GQRX is going to be the one that we're going to use to visualize our signal. So once you have both of your devices connected to your laptop, just right now I have chosen this to be PlutoSDR right here. I'm going to change this to 8 mega samples. That's perfectly fine. I'm going to click OK. So, and I'm going to transmit that on ISM band at 2.432 megahertz. This is where I'm going to transmit that signal at which frequency, and GQRX is, I'm going to use this for actually visualizing that transmission that is taking place of that Mersenne prime. I'm going to open up another terminal, and for that I'm going to use, so right now I'm going to turn on my PlutoSDR, and this is what's going on right now at 2.435, which is generally for your Wi-Fi, and this is what the transmission is taking place, as you can see it here. I'm going to increase the gain a little bit here, and everything looks good. There's transmission, you can see it in waterfall graph and things like that. Now the second terminal that I'm going to use this to actually open up, minimize this, and I'm going to use a command called HackRF transfer, which is basically a transmission command, and I'm going to try to transmit a signal at 2.435 gigahertz, that Mersenne prime. So what I'm going to do now, this is already inside my folder. As you can see, this is a text file that I'm going to transmit. I'm going to use a command called, let me clear this, HackRF transfer, which is the command that I'm going to use for transmitting that signal. So HackRF transfer underscore transfer, and when you hit enter, you would see there are different specification, different values that you can use to transmit that file. So what I'm going to do, I'm going to type in HackRF transfer, and then at what frequency I want to transmit. So I'm going to select 2.435, 1, 2, 3, 1, 2, 3. So 3 goes here, 3 goes here, and 3 goes here. So I need to remove. This is going to be kilo, and this is going to be mega. So this is the frequency that I'm choosing. The next thing I need to do is actually turn on the amplifier by using a tag A, typing it 1. So do turn on an RF amplifier for transmit and receive. I'm going to turn on my transmission gain, which is going to be tag X, and this can be up to 47 dB. So I'm going to choose this to be 47 dB. Next thing I need to do, I need to have a samp rate, so which is tag S. I'm going to choose a samp rate of 1 mega, And then next I need to transmit a file. So for file I need to use -t, and I want to select the file. So -t, and it's going to be text file, and I'm going to continuously repeat this transmission by using a tech capital R, because capital R to repeat transmit mode is turned off. You need to turn this on, and I'm going to hit enter. I hope it works. Let me just unplug this and plug in my HackRF, and let me hit enter. Let's see what happened. All right, sample rate should be greater than this. Okay, so let's change our sample rate to 2 megasamples, and let's hit enter. So as you can see, this is what a spectrum looks like when we are trying to transmit the largest known prime number to man as of right now. Of course, people are still trying to find new numbers, but this is what a spectrum looks like when you're trying to transmit a largest prime number, which is known to men as of today. And this is what a waterfall graphs look like. This is what it looks like when you're transmitting at 2.435 gigahertz, and this is how this signal looks like. So I hope you find this small tutorial. This is something for fun. I hope you find this tutorial to be helpful. If you have any questions, just leave it in the comment section, and don't forget to like and subscribe to my channel. And thanks for watching.